Welcome to PreMath. In this tutorial, we have got this trapezoid ABCD, as you can see in this figure, such that this line segment AB is parallel to this line segment CD, and moreover the area of this triangle BPC is given to us as 2021, and now we are going to calculate the area of this green triangle APD. So let's go ahead and get started with the solution, and I will show you the solution in terms of a small proof. And here's the very first step we are going to do. Let's drop a perpendicular from this point A onto this line CD. Let's go ahead and drop this one over here. That is going to be 90 degrees. And likewise, we're going to be dropping a perpendicular from point B onto this line segment CD as well. And here's our much nicer looking diagram. And one more thing, just keep in your mind, since these perpendiculars AF and BE are perpendicular onto this line CD, so therefore this line segment AF is equal to this line segment BE. And here's our next step. Let's go ahead and calculate the area of this triangle ACD, the one that I have just shaded. And here's the area of a triangle formula. Area equals to a half time base time height. And in this triangle ACD, the area is going to become a half time base. In our case is CD time height is AF. Let me go ahead and call this equation as equation number 1. And now let's go ahead and calculate the area of the other triangle BCD. I have just shaded this one. So the area is going to be a half time base, once again is same, CD, and then times the height is BE. And now we can see that this height BE is same as the height AF. So I'm going to replace this one by height AF. So therefore our area of this triangle BCD turns out to be a half times CD times AF. And I'm going to call this equation as number 2. And now let's go ahead and compare equations 1 and 2, and we can see the right hand side of these both equations are same. So that means we can write the left hand side equal to this left hand side as well. So thus the area of this triangle ACD turns out to be equal to the area of the other triangle BCD. And now we can see from this diagram the area of this triangle ACD is equal to these two individual triangle areas, area APD and the area DPC, as you can see in this figure. And now let's focus on the other triangle BCD. The area of this triangle BCD is equal to the area of this triangle BPC and the area of this DPC triangle. And now we can see this area of this triangle ACD, and this is equal to the sum of these two individual areas. So I am going to move this one right up here, and likewise on the right hand side the area of the triangle BCD is equal to the sum of these two individual triangles. So I'm going to move this one right up here as well. And here in this next step, I have replaced these areas of these triangles by the individual ones. And we can see right now this on the left hand side, this area of DPC and this area of this on the right hand side DPC, they cancel each other out since they are same. So we just simply ended up with this area of this triangle APD equals to the area of the triangle BPC. And we know that the area of this triangle BPC is 2021 square units. So therefore, the area of this triangle APD turns out to be 2021 as well. So thus the area of this green triangle APD turns out to be a 2021 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.